So, here in week 13, we're going to start a new topic. And this topic will be object oriented programming. So, set up an 027 intro to OOP, create an index and a main where no need to copy any code from before, and then code along with me. So, just to set up this topic, because it's huge, right? You remember the everything's an object in JavaScript meme, right? I don't have to go find it. Hopefully, you remember it. Because everything is an object, but there's different techniques, different paradigms for creating objects, okay, in JavaScript. So we have been using, and I flash back to the week or 018 where I had you, and I said at the time, we're pretty much academically creating this one object to hold all the values, the keys, in this case, the arrays, right? And the functions, which we then call methods, right? So it was somewhat academic because what we're doing this in is an object literal, okay? And literal objects have a wonderful ability to store data, to store functions, but they're not really intended to do what we call factory functions. Now, factory functions, and we use classes for them. And today, and I'm curious actually to know if any of you have been playing with Chat GDP, because I thought, I'm going to ask just this question, like, what is OOP in JavaScript? It's in a paradigm for emphasizing the use of objects, right? That can contain data and methods. So what we're really doing is we're trying to emulate the idea of a real thing in the real world, right? Like we have data about us, we have methods that we do, working out, reading, right, to model and to solve problems in the real world. And so JavaScript supports OOP, of course. And this is what I mean. We've been using literals, okay? But in JavaScript, you can also do something called factory functions, which aren't quite as prevalent today, or constructors, which I'm going to show you after. But we're really just going to say, let's use classes since it's pretty much the most relevant. And there's not a huge difference, although it will look like it, between a class and a constructor, because basically they took the constructor and they made it more look like Java traditional. Now, and this is what I kind of laugh, is because some people think Java and JavaScript are the same. And if you've taken Java, you clearly know they're not, right? But in this case, the reason we got classes in JavaScript was because traditional Java programmers wanted them and lobbied, because there's a committee, right, for ECMAScript. There's a whole committee that goes through and says, here's the latest updates to the language. But in classical object-oriented programming, right, we have objects. Like I said, this is what we've been, and this is really what we did in that 018 directory, right? We related behavior, related data, and behavior together. But there's a real downside to this, right? And the real downside is that it's expensive from this perspective. Like if I was to do like tracking object, right? So here's the object I set up. And if I look at tracking object, okay, it shows me the object. And what happens is all of the methods, in this case, the functions, are attached to the object. But where we really start to benefit from object-oriented programming is when we can first create a bunch of objects, okay, that then have a chain of prototype, a prototype chain or prototype that we can then reference functions that will then be able to be run on each of the objects. I'm going to show you this in a minute, but I just want to give you like what was wrong with this. It was done as a good way to introduce some concepts, right, of gathering together some data and some related function in just an object literal. But as we move forward, we want to be able to to basically have and I'm using the term factory function, but there's actually a specific program paradigm for factory function, but it's basically a way to create objects. Okay. So what we're going to do is we're going to show you classes. I'm going to show you classes today, but it's to define an object's blueprint. So you can create multiple instances of objects that share the same properties and methods. And man, is that important. So then as we create our first one, then we'll start really talking about the principles of just showing you, like, when we do this, we get inheritance. When we do this, we get encapsulation. When we do this, I don't know if we'll get all the way to polymorphism, but it's the idea. So here is kind of the tenets of OOP. Okay, but I love this. Is developers to create objects that can encapsulate data and behavior, organize code in a structured modular way. And you might think, well, didn't we do that with modules? And yeah, we did, but we just organize the code. And in this case, we want to also organize the data and the behavior, which is a higher, more sophisticated way of doing it. Okay, so that at least gives you that introduction. So now what I'm going to do is I'm actually going to come over here because I have running locally. Let me go to my O27. I'll go ahead and set that up. Okay, so in here, I already have it running. Okay, and we're going to come back to this in a minute. But in our code, right, so in our HTML, in our JavaScript, we're actually going to code our first class. And we start with the class keyword, okay? Now, there's different ways you can write this class, okay? But this is kind of the classical way, and we're going to create a person class, and that's kind of also the general first way you see a class. If you see examples, often it's that. And so what we have to do is we have to first create a constructor, okay? And you'll see basically the constructor is saying every time you create a person, it needs to have these values in order to do that, okay? In order to create that person. Now, first I'm going to show you just kind of the hard-coded way. And now remember, we've talked about the this, so it's the context of and this is a blueprint. So we're going to end up creating examples of different people, but in this case, it'd be this would refer to the substantiated object. Okay, so we say this dot first name equals, right? Now, in this case, we're not, you might think, when we're looking at traditional object literals, right? Sorry, we don't do it this way, right? We do it this way. Okay, that's the way we do it. Then we do it with a comma. So when we're doing classes, we have a different syntax. So we do equals, and you can still do a semicolon. So it'll be this dot last name equals. Okay. Now, in this way, I am basically hard coding this object. Okay. But I do this just as a beginning to get you used to, right, the idea. Address equals, right? Now, of course, 1, 2, 3, no way I'm going to share it. We'll talk about this later, okay? But you get the idea. So now, okay, so now when we come down here, what we do is we'd say, right, const, because now we're going to say create a new object, okay, equals, right? And in this case, we actually use the new, and this is the key. And we've seen maybe, no, maybe not new. Yeah, I showed you new array. I've showed you maybe new date. But in this case, when we call new, we're saying, look at this blueprint and create an object, okay? So if we do new, right, and then I would say person, and then I have to, in this case, invoke it, okay? All right, so that is its basic structure, okay, just from a syntax perspective. So let's go over and look at it, right? Come over here, and then right here, if I set a breakpoint, let me make this a little bigger so you can see it. Right, so if I set a breakpoint right here, I reload the page, then I'm like, okay, step into this. So this dot first name, right? This dot last name, and as we work through it, then what happens here, and you're used to whenever something gets returned. Like if we've defined a variable, that means there's something returned. But in this case, it's implied in a constructor that what it's returning is a new instantiated object, okay, with this, in this case, this data right now, okay? So if I go step into this, then I now have a new object that has those values that were sent, that were hard coded into the, in this case, into the constructor. So it constructed, right? It's a blueprint. It constructs an object, right? We call new. This is the first time we've really literally seen that. And then we called the class itself. Okay. So now let's come over here and add now a function, right? So like show status. Okay. So this would be a method. Okay. Remember now this method, it looks a little different from what we've seen before, right? And so we say console.log, right? And we could say backticks this. Oh, remember we have to do the $, right? This dot first, oh, dot first name lives at. Okay. Then we'd say this dot address. Okay, so now what we can do on our instantiated object, okay, which is, I'll never forget the first time somebody mentioned to me an object had instantiation. I didn't understand it. And for the longest time, I asked people to explain it to me, like when I was new into programming, and nobody gave me a good example. So, what I want you to know, it's basically a new object created from a template, or in this case, a blueprint that has both data and, in this case, methods. Okay. So now, in order for me to call that, I would say reference my new instantiated object dot show status. Okay. Now I do have to call it like that. Okay. So let's go ahead and let that run. Right. So now we're back here. Oh, we don't need to watch this run. We know what this is going to do. So now we have this new object, right? And we say this dot first name, cool, right? Lives at no way I'm going to share. Okay. So when we look at it, and here's what I really the reason I showed you this. If I look at the uh, object that we instantiated based on the class, okay, we see that it's referenced. And by the way, I didn't mention this and I should have, but we do use a capital. It would work without it, but it's really a way we do a visual for people writing this that understand that when it's a capital, okay, and I believe they call this Pascal case. Normally we've been using camel case like in here, but in a class we capitalize the first letter of the class name. And so in down here, right, notice how when I showed you the mileage before, it had it in there, but it also had the functions, the methods setting on, right, the instantiated object. And now in that case, it's not instantiated, but it's still just an object. But now when we roll down into prototype, we can see that now anytime we create a new person, right, from this template, that shows status, right, doesn't have to be written for each new person. It is referenced through what we call the prototype chain. Okay. It's basically saying, hey, if you don't see it, right, our first, like, so let me just show you. So here's the show status, right? So before, when we had the literal, we had the methods setting on the highest level of the object. And in this case, we have the data because that's unique to that instantiated object. But this is a method that no matter what we create, again, from this kind of factory function idea, we have these both methods, and it shows the constructor because this constructor is part of that. Okay, so let's just go create another one. Okay, But actually, let's actually do this a little differently, because you wouldn't normally, if you're doing a factory function, you'd want to be able to pass in, right, some information. So this wouldn't make sense. So how about if we pass in first name, last name, right, and address. Okay, so if we do that, if we pass these things in, then this would be equal to first name. Now you see people name, they often will try to come up with names that are different, because sometimes in reading that, people might find that a little hard. But basically, you're saying whatever is passed in, then this, set to this context for that substantiated object. Okay. And then we'd say address. Okay. Okay. So now when we call new person, right? So I'd say Rio, right? Comma, Waller, okay, comma, 2, 3, no way. I will share it. Okay. All right. So now this is taking it kind of to the next level, which is more like the way you would do it. So let's actually do this, right? So let's actually create a now it'll error out, and we could say Jane, right? So it'd be Jane, we'd pass, right? So 1, 2, 3, how about 1, 2, 4, make up an address. Home, whatever. Okay, you get the idea. I'm actually using this address for something specifically we're going to see later. Okay, so now I can call Jane show status. Okay, which is the whole point of me showing you first modifying this to say it, because this is a paradigm of creating multiple objects, right? Can imagine like everything, all the data we're creating is better managed when we're creating it with a template in mind. Okay, so let's move over here now. Let this run. Okay. I'm gonna stop that. By the way, if you ever have a breakpoint because you've written more code, then it changes that. So what you can do is hit play. In this case, I don't think I have another one, so it'll just play all the way through. Okay, so now because Jane is setting out, right, I can do Jane, and Jane is a person because it was built with the class, right? Again, we have the data that is unique to that new instantiated object. We have the prototype, so we still have show status, and I want you to kind of hone in the difference between. So here's what I want you to do in your README file. Tell me if you now understand the difference between the way we were creating objects before and the way we're creating them now with the class syntax. Like I said, there's multiple other ways to do it, but just with this syntax, do you see the difference that I've been talking about around the methods and where they're located in the object? Okay, give me some of that syntax, and then we'll go ahead and commit this, and we'll pick it up on the next one, because now we're going to actually do the kind of the next logical step with some of this.